Hello boys and girls. In this video we will show you how to use these three equations for accelerated motion. Each time you need to solve a problem for some kind of motion, use the following steps. Read carefully, visualize the problem, sketch a velocity time graph, write suvat and show what you know, calculate, and finally check your answer. We will show you how to apply these steps in the following two examples.
Okay, we're going to use this approach for example number 1. In example number 1, Mr. Koopman starts cycling from rest and accelerates uniformly for 8 seconds with an acceleration of 0.75 meters per second squared. We are asked to calculate his velocity after 8 seconds and the distance traveled in these 8 seconds. Well, step number 1 will be that we have to go to visualize it. Well, that's easy today because I have a film of Mr. Koopman actually cycling here. So let's have a look at that film first. He speeds up. As you can see, it's clearly Mr. Koopman. Okay, thank you, Mr. Koopman. Okay, step number 2 is to sketch a graph of what's happened here. Well, we know we have to draw a velocity time graph. Mr. Koopman started cycling, so the graph will start over here in the origin. And he accelerates uniformly, which means that his speed will increase at the same constant rate. So it will be a straight line going up, something like this, which ends at 8 seconds because then we will stop after 8 seconds. Okay. That's our velocity timer. It's a sketch. No numbers are required yet. We just sketch to see what happened. Okay, step number 3 is to write down our suvat list and to show what we know. Here is the suvat list, and I already put in the initial speed 0. He started. I don't know the final speed, so question mark there. And the acceleration 0.75 meters per second squared and the time 8 seconds. We have to calculate his velocity after 8 seconds, and we can do that in several ways. First, I will show you how to find that final velocity just by looking at the meaning of acceleration. His acceleration is 0.75 meters per second squared, and that means that his velocity increases by 0.75 meters per second every second. So if he accelerates for 8 seconds, then his final velocity will be 8 times 0.75, and 8 times 0.75 makes 6 meters per second. If you prefer to use the formula, it goes like this. First, we take this formula, which leads to the final velocity v, where the initial velocity is known and the acceleration time are given. In this situation, if you look at the list, they're all there. So I can just simply fill in everything and calculate, which leads to this. Here you can see final velocity 0 plus 0.75 times 8 leads to 6 meters per second. We can put the 6 meters per second over here in our graph. To find the distance traveled in these 8 seconds, there are 3 different solutions. I'll show you the 2 easiest. First, don't forget that distance traveled is always equal to the average velocity times the time taken. In this situation, we know that the initial speed was 0, the final speed was 6, so the average speed is the average of 0 and 6, which is 3. The time taken was 8 seconds, so it's not hard to find out that the distance traveled must be equal to 3 times 8, which makes 24 meters. Another way to find the distance traveled is to use this formula over here. Again, we know everything which is needed to solve this problem, so I can simply fill in everything and put it like this. The calculations are a little bit more complicated, but if you solve this properly, use your calculator, you will find again that the distance traveled is 24 meters. But there is another third way to solve this problem, and it is with the use of our velocity time graph. In our velocity time graph, the total distance traveled is always equal to the area under the graph. And this is a nice graph. The shape of this area is a triangle, and the area of a triangle is simply half times base times height. In this case, a half times 8 times 6. A half times 8, 4 times 6 makes 24 meters. So again, it leads to 24 meters. Now you can see that the area is shaded here, and shown is that the distance equals half times base times height. A half times 8 times 6 makes 24 meters. So what I've tried to show you is that there are more ways to solve a problem like this. It's up to you to choose one of them, the one you like best. Don't forget that always you have to check your answer. So in this case we have to check that 24 meters, does that 24 meters make sense? Well, try to remember the film you've seen. You've seen Mr. Koopman traveling for a distance which is something like 24 or 20 meters. So I think the 24 meters we found here must be the correct answer. So let's have a look at example number 2.
Example 3. Mr. Koopman is cycling at a speed of 6 meters per second when he sees the traffic light changing to orange. Then he uniformly accelerates with 0.5 meters per second squared for 4 seconds and passes the traffic light the moment it changes to red. Calculate the final velocity and the total distance traveled in these 4 seconds. Step 2 is to visualize the situation. So let's have a look at the video. Step 3 is to draw a velocity time graph. Now we know that at t is 0 seconds, Mr. Koopman is traveling at a speed of 6 meters per second. So let's put a dot over here. After 4 seconds, his speed has increased, which means the graph will go up, something like this. And remember, it's just a sketch. Let's draw a line between these 2 points. Now fill in what you know. You know the speed or velocity is 6 here. We do not know the final velocity, but we do know that the slope of this graph is 0.5 meters per second squared, and we know the graph ends at 4 seconds. Step 4 is to write suvat and fill in what you know. Here's suvat. S, the distance traveled, is one of the questions it's asked, so we do not know this quantity. The initial velocity is given, it's 6 meters per second. We do not know the final velocity, it's also asked, and we do know the acceleration, it's 0.5 meters per second squared, and we know that this takes 4 seconds. Step 5 is calculate, and let's first try to calculate the final velocity. And let's see what formula we can use. Now this formula says something about the final velocity and the initial velocity. Fill in what you know. V equals 6, the initial velocity, plus 0.5, which was the acceleration, times time taken, equals 8 meters per second. And we can fill this final velocity in our graph. Fill it in our graph. Let's put it up here. Now the distance traveled is given by the area under the velocity time graph. And as you can see, the area under the graph can be divided in two pieces. First of all, this rectangle and this triangle. Now the area of this triangle equals a half times the base, 4, times the height is 2, which equals 4 meters. And the area of this rectangle is just the width times height, which equals 24 meters. So the total area, or the total distance traveled, equals 4 plus 24 equals 28 meters. Now there are two other ways in which you can calculate the distance traveled. First of all, you could have used this formula, and you may only use this formula for uniform accelerated motion. The first part represents the distance traveled at the constant initial speed, which corresponds to the area of the rectangle. And the second part corresponds to the additional distance traveled because of the accelerated motion, and this corresponds to the area of the triangle. And now if you fill it in, you will find that the distance traveled equals 6 times 4 plus a half times 0.5 times 4 squared. This part equals 24, and this part equals 4, and together it's 28 meters. Now finally, you can always use that the distance traveled equals the average velocity times the time taken. And for a uniform accelerated motion, the average velocity is just the initial velocity plus the final velocity divided by 2, which is given in this formula. You see, the initial velocity plus the final velocity divided by 2. And if we fill it in, you will find that the distance traveled equals 6 initial plus 8 final velocity divided by 2 times 4, which equals 7 times 4, and finally, it's not a surprise, it's again 28 meters.